So with that, Carl, the floor is yours.
Thank you so much, Lori, and welcome everybody to today's seminar. Where I think this is always one of my favorites. These types of sessions because we are going to do a few PowerPoint slides to get some housekeeping things out of the way, and then my colleague Ed Gilman out of our Denver office is going to be doing the heavy lifting. He's going to show you the picks and clicks and the cool stuff behind the manufacturing strategy. So we'll intro Ed a little bit later, but again, just to get some things out of the way, today's presentation is brought to you by Imaginative Technologies. We belong to an umbrella company called Rand Worldwide. Our sister companies are Rand 3D and Ascent, all big players in the world of CAD and CAM technology. So in today's world, and I want to talk a little bit about manufacturing and the strategy from from an administrative standpoint, why Autodesk is doing what they're doing and how they're getting it done, right? So Autodesk realizes that things are just becoming more and more sophisticated. Technology on how things are made and materials that are making them and everything is challenging the status quo. I think all of us who've been around for a while have a traditional view of a manufacturer, just like the view on the right there. You know, products on the left are what we realize today. The way they're manufactured is on the right, and that's the view we all kind of have of manufacturing, but we know that's changing. The status quo is changing, and it's something as things change and people go from wearing aprons to lab coats to work in the manufacturing environment. Products are becoming more sophisticated. The manufacturing technologies are becoming more significant and sophisticated. Everything is at the precipice of a new era, right? So everything is going to be a change, and we just have to realize all this in line with the future. And Autodesk is no different. And what they've done for the manufacturing environment from a technology standpoint is a pretty exciting time to be around. Autodesk realizes that when they do these studies that things are becoming more suited to human needs, more customized, more configurable, more connected, all that kind of stuff, more valuable to you, right? So even a car is just not a car. It's it's an entertainment system. It's a social media device as well as a transportation. All kinds of stuff. Everything is connected. When it comes to the realm of making things, it's new technology is being introduced all the time. Additive materials. I mean, now you can print with metal, right? Fascinating new additive manufacturing technologies emerging out there. And in the world we work in is changing as well. The process, the way we design is changing as well. As I was coming up, most manufacturers delineated between, draftsmen and designers and engineers, and now that's all kind of converged where everybody's doing a lot of things, especially as we're starting to end the manufacturing process and take advantage of, a one source or a standardized solution to get it all done with one model. So again, Autodesk has been for years taking a look at what's happening, what's going on, where we're going to be, and you've heard of it as a strategy called the future of making things. We've been talking about it for a number of years now. They've been investing in technology and investing in solutions that are going to attack these issues and figure out what to do with them. So let's take a look at what they've done. Now, I get asked all the time, what the heck is that? So, that's a floppy disk. There may be a bunch of you out there who really don't know what that is, but suffice it to say that computer technology over the past 35 years has changed a bunch, and AutoCAD came along as the AutoCAD company, right? But as AutoCAD has grown and developed and attempted to conquer the world of design engineering, right? They've foreseen how manufacturing and design has converged, and they've made some significant investments. So just over the last 14 years, Autodesk has invested in a bunch of world-class technology that they can incorporate into their workflow. This isn't, by the way, off to the side stuff that they're adding in here. These aren't add-ins. These are Autodesk products that they have purchased and integrated into their system. All of them involve all types of manufacturing process. Now we're going to focus on a couple of them that came about with the HSM Works technology acquisition as they integrated the CAM workflow inside of Inventor and inside of Fusion. And then we're going to see a little bit about the Delcam acquisition, which is the FeatureCAM, Power Mill, stuff like that. So we're going to focus on some of the manufacturing process from Ed's perspective, but just take a look at those acquisitions right there. That's all high-end manufacturing technology that's all been absorbed and made available to our clients. And it kind of encompasses the entire manufacturing workflow and process, from the planning stages, the engineering stages, if you will, on how things are going to be built, all the way through programmatical issues, on productivity analysis, understanding how things are supposed to work from testing, all that kind of stuff, all the way down to production, getting it out on the shop floor. These technologies are all integrated to get this whole process done. Now, those of us who came up around the CAD world knew it is design program, and then we handed it off and disappeared, right? Until it was handed back to us and we made a change. And then we handed it off and disappeared again, right? So this is what this is all meant to accomplish, getting all of that integrated, filling that gap, and making sure that things don't disappear. Everybody knows what's going on. This has all been accomplished from Autodesk's perspective with over 600,000 software developers. A billion, larger than a billion. It's way over that now. $1 billion invested in technology for Autodesk. They even do this manufacturing innovation centers. They're scattered around, a couple of them in the U.S., several of them overseas. But what they do this innovation technology manufacturing, the machining centers, where they actually do physical manufacturing using Autodesk technology. This is the best prototyping you could do to figure out where the gaps are, what things need to be fixed, what things need to be adjusted, and adapting to the real world situations in the manufacturing workflows. Now, they do all this with the support of 40 partners globally. These partners they're called make partners, specialized partners who jump through a bunch of hoops in order to provide you not only with the best in class technology, but the support and education and integration expertise to get this into your system the most efficient way possible. And imagine it, my team that I head up, as well as Ed, who works for this team as well, are all part of this specialized make partners, and we're so tickled to, again, part of this emerging market and to drive all of this stuff forward and help integrate it into the marketplace. So we're going to focus on a couple of things today. We're kind of looking at a little bit of Fusion 360. Now, when I say Fusion 360, I don't mean to imply that Autodesk Inventor, our premier hero product for 3D solid modeling, is left behind, right? So the maker strategy is embedded inside of Inventor as well for on-premise stuff. So if you're an Inventor house, and the make strategy, the make tools, the manufacturing extensions are all available to you there. We're just going to kind of focus a little bit on Fusion 360 because it's the new kid on the block. It's the cool stuff, right? It's got some really, really nice technology in it through their advanced manufacturing extension that Ed's going to talk about, from both the design and the generative design stuff that's in there. Again, I'm not going to touch too closely on that, but fascinating new technology that nobody else has. We're going to talk a little bit about that in Fusion 360 today as well. We're also going to talk a little bit about some of their advanced productivity tools for manufacturing in the name of FeatureCAM. There's several of them, right? Feature recognition tools, nesting automation tools, automation tools that are just going to that understand how things are supposed to be built from a generative design technology. Show me these are my constraints. Show me how to build this kind of thing, right? Now, FeatureCAM, if you're not familiar with it, is part of the advanced manufacturing strategy. It can be embedded inside of Fusion, so you can have a true CAD/CAM technology there. It can be purchased as a standalone, however, whatever fits your system, right? But FeatureCAM basically automates the workflow. So in the typical machine environment that Ed's going to talk about, you kind of look at something, know your tribal knowledge, understand, okay, I've got a hole of a certain diameter, a certain depth, and my materials a certain hardness, all that type of stuff. And your tribal knowledge will dictate feeds and speed rates and all that kind of feed rates and speeds and fluid coolant and all that kind of stuff. That's all based on tribal knowledge. When to turn it on, turn it off, how fast to go, how fast to plunge, all that kind of stuff. With FeatureCAM, you kind of automate that. You kind of take a look around and it understands features and it understands what to do with them. So if FeatureCAM encounters a hole or a pocket or a boss feature or something like that, it understands what to do with it based on how you set it up, based on your libraries and how you set it up. So it says, okay, I understand the material, understand the hole diameter, understand the hole depth. Here's what we're going to do to it. So it eases the whole process of the mistake-prone, relying on tribal knowledge stuff that comes about. So you'll see both today. A little bit of Fusion, a little bit of FeatureCAM. Here's where I get to step aside and let my friend and colleague Ed Gilman take over with his technical presentation on the whole tool set. Ed, are you there?
All right, sounds good. Thanks, Carl.
I'm trying to see how I can turn the. All right, I'm seeing your notes on your desktop.
Let me see. Let me share the screen here.
Yeah, great big button on the panel that says show screen.
Yeah, I don't know why it's not letting me share the other screen. It worked last time. Let's see. Not exactly how I wanted to do it, but we'll just go with it for now.
There we go. We're seeing it.
All right. Well, thanks, Carl. We'll go ahead and jump into the demo side of things. This is where you guys get to see the magic happen a little bit, see some of the offerings that Autodesk now has in the advanced strategies. So kind of what Carl had mentioned before, Fusion 360 is where I'm going to start. And the way that Fusion 360 fits into the advanced make strategy is it's a great tool for people that and manufacturers that are doing a lot of one-off parts. So this may be unique components to your workflow. This might be a prototype for a new design. This might just be some fixturing or some tooling that you need for to support some other manufacturing processes, or you need for one of your other machines. So when you're in the scenario of making changes to your design and needing to quickly prototype something or make changes quickly to something, Fusion 360 does a great job of that. So that's kind of where it fits into the make package that Autodesk provides. So Fusion 360, I have it up here. This is included when you purchase FeatureCAM now. So if you do go forward and you buy FeatureCAM for your machine, you get this really high-end 3D modeler of Fusion 360 that can also do CAM. It can also do simulation and generative design, like Carl mentioned. And all of that is right here in Fusion. So you've got your design capability. These are things like sketching and modeling. You can do generative design, where you're actually looking at potentially new ways of designing something or building a component based off of input stresses and strains. You can do some rendering, animations, simulations, so full FEA, linear and nonlinear FEA, as well as then the manufacturing and drawing workspace. So we're going to be focusing mostly on design and manufacturing today, but keep in mind, this is just included with FeatureCAM now. So you have all these great tools for improving your designs that are a great complement to what FeatureCAM already offers in the automated CAM realm. So looking at what we have here in Fusion, I've got my design, I've designed my vise, and I want to go ahead and add some CAM programming to this. All I have to do is jump over to the manufacturing workspace. First step is going to be creating the stock setup, which I've already done, so you guys don't need to be bored with me creating a stock block. But the nice thing with the stock setup in Fusion is it allows me to choose the size of my stock. So you'll see that yellow box there represents the material. But also you'll notice here at the bottom, I can choose components that are fixture bodies. So I've chosen these 5 components here as my fixture, which means number one, it will avoid colliding with these. And if there is some type of collision with either the shank or the holder on your machine, when you go to simulate this, it'll give you a warning telling you that you plunged too deep or you have a retract move that's colliding with the fixture. So Fusion 360 has some great collision avoidance features built right in, makes it easy to simulate your workflow. So on this part, let's say we wanted to come in here and add some CAM programming. Real simple, you've got all your operations up top. Say I want to face this off, I'm going to click on face. Open up my tool library. Tool libraries can be fully customized, right? So you can customize every single tool. So whether it's the cutter, the flute length, maybe it's the feeds and speeds you'd like to use. You can build out libraries based off of the machine. You can build out libraries based off of the material. So you could have an aluminum library where you set all of your feeds and speeds based off of aluminum. You could also have a library based off of steel. So in here, let's just say I grab my face mill. I want to face this off. Maybe I want to add a little bit of a path extension as well to make sure my cutter gets clear of the stock. Click OK, done. Got my face mill operation in there. If I were to take this and post-process this right now for my Haas, I'm going to cut this on a Haas VF4 today. Let's say I post this out. We'll just go ahead and save it. It's going to give me the G code right away. So I've got my G code here that I can review. I'm opening this up in Visual Studio Code. This is a great program for making quick changes to your G code. So I can review that all of the M code and G code lines come in properly, and then I'm off and running. So then from here, I can just continue to add in my toolpath. So very visual based, very easy to use, very intuitive is how I would describe Fusion 360. So let's add in some other operations. And I want to show you guys sort of how this Fusion 360 integrated CAD/CAM really can benefit you when you're making modeling changes. So for instance, let's say I was adding in a toolpath that's going to machine out this central pocket right here. Well, I'm just going to go over to my adaptive clearing strategy and grab a tool. Let's grab this 1/2 inch end mill here. For my machining, let's say that we want to only remove material inside of this boundary right here. I'll go ahead and select that. And then for my cutting, let's say I'm comfortable cutting 1/4 inch at a time in depth, and maybe I'm going to do some step cutting of about 25 thousandths there. I'm going to leave some radial stock and then 0 in the axial direction. Maybe I want to leave a little bit there as well. So we'll just leave, let's say 10 thousandths of an inch in the radial and axial direction. So I'm just leaving a little bit of stock here. This is going to be my roughing operation. I'm going to go ahead and optimize the retractions a little bit. And you'll notice the cool thing about Fusion 360 is these tabs that I'm jumping through up top here, these are going to look exactly the same for every strategy, but the settings on each tab might change slightly. The nice thing with this is it makes the learning curve really quick. It's easy to train somebody because once you train them with one toolpath, most of the other toolpaths look the same. You're not spending hours digging through panels looking for something. So if we go ahead and we create our toolpath here, we'll go ahead and set the top, and we'll go ahead and set the bottom here. Go ahead and generate our 3D adaptive. The way 3D adaptive works is it manages tool load, which means it creates an optimal load on my tool. So it uses 40% of my tool diameter, the way I have it set now, to machine the material out, so it gets material off your part quickly. So I'll go ahead and simulate these first two operations here. It's going to bring in the tool and the holder, so you can see the tool and the holder there, and you can see the table and the fixture that I've already put in there. And so when I simulate this, it's going to simulate the motion of the machine and remove the material out of these two boundaries here. So it's really slick, really easy to use. And the biggest advantage here is that if you make changes, you're not going to have to re-import the model. You're not going to have to go back through creating all of those picks and clicks because it's an integrated CAD platform. Let me show you what that looks like. We'll go ahead and save this. And I'll jump over to the design workspace. So I have all of my design tools. And let's say that it comes back to manufacturing and this pocket here needs to be a little bit deeper, maybe due to some powder coating or something you're doing on here. It's not quite achieving the tolerance that you need. No problem. Come into Fusion 360 Design. I'm going to do a press pull, and maybe we just bring this down 10 thousandths of an inch. So I'm going to push that down 10 thousandths, click OK. Go ahead and save our part. So I made a quick little change there. Go back to manufacture. And you'll see the facing operation on the left as well as the adaptive operation are showing up with these red exclamation points. What this means is that the toolpath is out of date. not the end of the world. I can just go ahead and right click, and I'm going to generate both toolpaths. So it creates my facing operation, which isn't going to change, obviously, but my adaptive operation now does change, and it now matches that new geometry. So if you're making changes rapidly because it's a prototype or because you haven't quite settled on the design yet, you can just go ahead and update those CAM toolpaths without having to start over. And that's a massive advantage when you're trying to get something produced, get something on the machine as quick as possible. You're not spending all day dealing with those changes and having to export a file, bring it over to the manufacturing department, have them programmed again. You can just do it all right here from one interface. So that's one of the key advantages of Fusion 360. That's really where it excels. Now, another thing that you can get with Fusion 360 is a souped up version or an upgraded version of Fusion 360. You'll notice at the very top right corner of the Fusion 360 window, there's this extensions button, and this looks like a wrench. I click on that. There's 3 extensions you can purchase. These are additional costs. So the machining extension or the manufacturing extension in here gives you a couple of new options, and these have been updated this year to add quite a few advanced functions that are actually being pulled from FeatureCAM and PowerMill. Things like hole recognition, so some automated hole recognition that comes from FeatureCAM. The steep and shallow strategy that originally came from PowerMill. The steep and shallow strategy is great for doing molds and dies, typically where you have surfaces that are different angles. So you have some steep surfaces, you have some more shallow flat surfaces. It changes the toolpath strategy to be optimal for those automatically. So steep and shallow and hole recognition are examples of some automated programming. There's also toolpath trimming, which allows you to just trim away unwanted segments of your toolpath. That comes from PowerMill. These are really advanced machining strategies, as well as 5-axis collision avoidance, that all you need to do is just purchase this extension. It can be purchased sort of as a 6-month or 1-year version, or you can actually go month by month. That's around $100 per month. And what that means is then you can buy it for 1 month that you're using it, and then you can stop paying after that 1 month. So it's a really flexible add-on, and it makes these tools very accessible to everybody. So if you're looking around this year for Christmas gifts and you haven't really decided on something yet, may I just recommend that manufacturing extension? That would be a great Christmas gift for you or maybe for your boss just to try out with Fusion 360. So how does that work? So I have purchased it already, so I have it integrated into my Fusion 360 platform, which means traditionally, if I were to have to go and program these holes, I'd have to come in and do a drilling operation. I have to go select my tool, and let's say I want to do a spot drill first. I have to go find my spot drill. I have to then go select my geometry. I have to go select, let's say I'm doing these holes. I select those holes. I have to then come in here and set my height for my spot drill. So this is going to be, let's say I'm doing 50 thousandths of an inch spot drill. I'll add that toolpath in there. Then I have to go select my drill. I have to figure out what diameter this is. So I have to come in here and click measure, maybe go figure out what this is. It's a 201-inch diameter hole. As you can see, it's already becoming quite a lengthy process just to drill some holes, right? How hard could it possibly be to drill holes? That is where the hole recognition feature comes in handy. Rather than having to go select my tools, select the holes, choose the strategy, and spend 10-15 minutes programming these holes potentially, I can just do it with one button click instead. So we're going to go ahead and delete that spot drill out of here. I'm not really feeling like taking the time today, so I'm just going to go ahead and go up to the hole recognition feature. And what it's done is it's gone through, and as I'm selecting this, I'll zoom in a little bit. The first hole it finds is this larger hole in the middle, and it says, we're going to ignore that. The reason it's ignoring it, because anything that's larger than 1 inch, I believe, it's going to assume that we're going to do with a flat end mill and bore it out. So it's going to ignore that hole. It's going to ignore that hole. And then the next one right here is one of our smaller diameters. It's doing a spot drill and drill. The next size up, it's doing a spot drill and drill. So I can change the strategy if I'd rather do a drill and bore or a drill and ream. I can also do a drill and tap. So it recognizes all of these. It gives me a cycle that it's going to use. It also chooses from the tool libraries that I provide. So right now it's just pulling from my general inch library. So it should be able to find tools for all of these. If it doesn't, it'll give me a warning. So I'll click OK. It looks into the tool library, it finds the tools, and it's created the tool path to spot drill, counter bore, and through drill, all of those holes in my part. So in some programs, it might just be a couple of holes you're drilling, but if you're doing a part like this that requires, 10, 15, 20 different holes of different diameters and depths, hole recognition is well worth purchasing that manufacturing extension. It's going to make your life a lot easier. So now if I simulate this, I haven't removed all the stock out of there, obviously, but once it's done with that pocket, it's going to go ahead and go right into doing my spot drills, counter bore, through drill, and just like that, I've got all of my holes programmed. So again, just to recap, Fusion 360, it's integrated. So when I make a design change like I did to this pocket, it's really quick to update. But it's also flexible in that you can add on manufacturing extension features if you need a little bit more. Maybe you're not quite getting enough out of the base package. You want a couple of extra features to show off. You can go purchase those. And again, I highly recommend that as a Christmas gift this year. So how does this come with FeatureCAM? So how does FeatureCAM compare as part of the make strategy? So let's go ahead and show what it would take to program this with FeatureCAM. So we'll go ahead and pull up FeatureCAM. It's going to look a little bit different. FeatureCAM is a standalone product, which means it installs right on your desktop like Inventor or like AutoCAD or one of those desktop products. So it's not cloud-based. You don't need an internet connection to save your work. And you can bring in parts from anything you want. So if you are using Fusion 360 already, that's great. You can just bring it right into FeatureCAM. Maybe you're using Inventor. Maybe you're using SolidWorks or Creo. If that's the case, you can import any of those files directly into FeatureCAM. You don't have to go through any complex conversion process or anything like that. So let's go ahead and bring this right in. We'll just go ahead and do an import. I'm going to go grab the file, which I exported out of Fusion 360. And it opens up this window where it's going to walk me through the entire process of setting the part up as well as recognizing features. So the nice thing with this is it helps with training because you don't have to be an expert on this. It's going to ask you the right questions. You just have to kind of know what the answers are going to be. So as you go through, it'll say, well, which direction you want Z to be? Well, I want it to be perpendicular to this surface. Great. Next question. So it's kind of like a little questionnaire that you go through, and it's really slick. It's really easy, and it makes learning the software a lot easier. So we'll click next. What stock do you want? I want a block. What size do you want it to be? Well, I already know that this is going to be a certain size, so I'll just go ahead and type this in. You can also have it automatically compute the size if you need a specific size block for your part, but I'm just going to go ahead and size it the same way I did in Fusion, and we'll position it off of the top 50 thousandths of an inch like that. That looks pretty good. We'll go ahead and click on next. Where do you want the work coordinate system to be? I'm going to go ahead and use the top center of the part of the stock, so we'll go ahead and choose that and keep working through, and I'll click finish. It's done. I've got my stock set up, and now I can get right into my features. One of the things that I like to do before I start throwing in toolpath is make sure that I have everything accounted for. So one of those things is going to be fixturing. There's nothing worse than damaging a tool because you run into a fixture. So what I'm going to do to improve the safety a little bit is I'm going to go ahead and go into my import vice add-in. This is a add-in that's included with FeatureCAM. And I'm going to position this along the X. We'll go ahead and say that I'm going to clamp onto, let's just say I'm going to clamp on 1/8 of an inch of the part. I probably can adjust that as I go, but we'll start with that. And I'll click on import. Going to bring in my vise. And it actually positions my stock in the vise and clamps it for me. If only it was this easy to do on the actual manufacturing floor, right? If only some robotic hands came out of nowhere and set this up. So it goes ahead and throws that in there, just like that. We've got the vise clamping onto our stock, and now I can be safer and make sure that my toolpaths, when I add them, are not going to cause any unnecessary collisions. So really cool feature that FeatureCAM has. It automates your programming, but it also automates your fixturing. So let's go ahead and add some toolpaths. Let's say we're going to go ahead and do automatic feature recognition. What it's going to do is it's going to look at what are called my machining configurations. So it goes through and it looks at my preferred settings. So things like step over, what type of coolant am I going to use, what is my preferred depth of cut. It's going to look at all of that and determine how to cut this part out. It's also going to look at the material, which is in this case aluminum, and it's going to set my feeds and speeds for aluminum. And lastly, it's going to grab from my tool crib. So I have a tool crib that I defined with all of the tools that I have available. It will look through that tool crib and find the tools required to machine this part. So we'll go ahead and go right through this. Again, it's a flyout window. It walks you right through, and it says it found all of these features. So it found the holes, it found the pockets. And I can just go ahead and add that program right in here. Now, what if I am machining most of this with my CNC, but then I want to transfer this over to my wire EDM to cut out the outer profile? Maybe that's going to be more efficient, and that's typically how I do this. The great thing about the Autodesk Make strategy is they have made the investment in all of these softwares so that you don't need to go and have 5 different softwares just to program one part. I talk to so many different manufacturers each week that I'll be talking to them about their CNC machine, and they'll mention that they have a wire EDM or they have a laser that, you know, maybe they're just programming it by hand because they don't have the software to run it. Maybe it's just too much of a pain to program with the software that was provided. You might as well just standardize everything to one platform so that if the guy that normally programs your wire EDM, maybe he's out sick for the day, you know, that machine's not sitting idle because you have a cross-trained team. You have one platform that everybody knows, and it programs all of your machines. There's huge benefits to that. So in this example, let's say that I am cutting this on the wire EDM. I'm just going to go ahead and find that outer side feature, which is going to be, I think it's going to be one of these here. So it's the side 4. I'm going to go ahead and ignore that because I'm going to be machining this with my wire EDM, so I'll ignore that. I'll just click finish, and just like that, I have my program. We'll go ahead and simulate this in 3D. It chooses my tools, it chooses my feeds and my speeds, and it automates selecting all those pockets. So with Fusion 360, I would have had to go in there and select the tool, select the tool path. I'd have to do a lot of manual work, which requires some of that tribal knowledge that Carl talked about. You have to understand how to use the software, but also, you know, what feeds and speeds to choose, what step overs to use. But with FeatureCAM, you can set that all up ahead of time so that if you have a new person programming, they don't need to necessarily have all of that tribal knowledge. They just need to know how to use the software and to check for collisions and things like that. So it automates selecting the tools, the feeds and speeds, the pockets, and once you're done, you've got this fully machined part that you can then program, cut, and then we're going to go ahead and transfer this over to the wire EDM. So we'll let it go ahead and finish out all the programming. And another advantage of FeatureCAM is that it's automating the programming, and it's also automating that G-code process. So after I'm done simulating this and I'm pretty happy with it, if you look over to the right here, it has a list of my operations. And then if I go to NC code, it generated all the NC code for me using the Haas VS4 post processor that I had set up. So in the background, while you're watching this fancy simulation, it's doing the labor and building this NC code file that I can then save out and load onto my machine. And I know that it's going to run properly and efficiently. So that's all fine and dandy. We have our G code produced. We're all set there. I can go ahead and stop the simulation. And let's say that we want to then program our wire EDM. Once again, I don't need to export this out and import it into another software. I can just go ahead and create a new setup. This is going to be setup 2. We'll just call this our wire EDM setup so I don't get them confused. And I'm going to change my setup type to wire EDM. I'm going to set my 0 in the center again. So top center of the part. I'll go ahead and click OK. So we've got a new setup we're working with here. I'm going to go ahead and hide my fixturing because I'm not going to have it necessarily fixtured the same way. So we'll just go ahead and hide that for now. And let's go ahead and add that wire EDM process. So the nice thing is it's all the same interface. It works the same way. It just gives me the ability to program with a different tool. So I'll go ahead and go to features. I could do this as a die or a punch or a side. Let's just say we're doing this as a punch. I'm going to punch this out. I'm going to extract its feature recognition from this 3D body. So we'll go ahead and click next. And it gives me an outline of all of these curves. So you can kind of see all these black curves have been created. It goes ahead and it recognizes all of the two-dimensional features. So I'm just going to select the outer boundary here and click next. And just like that, I've got my wire EDM punch feature. We'll go ahead and click finish. Click OK. And it's got our 2 toolpaths for our wire EDM. I've loaded in a FANUC wire post processor. There's a lot of different posts out there for your wire machine. We can also help get one set up for you if that's what you need. With wire EDM, the simulation will look a little bit different, but it is going to do the same thing. It's going to look at my post that I provided and generate the G code in the background. So I can go ahead and do a 3D sim. Shows the wire cutting this out for the punch. So I can really quickly cut that profile, which is going to be a little bit more efficient than doing it on a CNC mill. And you'll notice then I go to NC code and it's got all the NC code for my wire. So I'm generating the 3D CNC program. I'm then programming the wire EDM. And when I go and I save this file, all the information is contained in the same place. So if you're looking for the CNC program, it's right here. If you're looking for the wire EDM program, it's right here. You can do all of your turning, all of your turn mill within FeatureCAM. If you need to do additive, Autodesk offers NetFab. So there's a lot of advantage to using these Autodesk Make products because you can standardize, you can bring everything into one platform. It makes cross-training much easier. And in general, it's just really going to streamline your workflow moving forward. So just keep in mind, FeatureCAM, you've got all this automation. You've got things like 3D simulation. I don't think I showed it earlier, but I could also do a full machine simulation. So when you're simulating, you could actually simulate it on your CNC machine. So you could build out a CNC machine file that looks exactly like your machine, which then shows the actual motion of the machine table, if that's the case. And this is going to make things a lot safer. So FeatureCAM, got all those tools. And then again, like I mentioned before, Fusion 360 also comes with the FeatureCAM purchase, and it gives you that access to those advanced 3D modeling tools, as well as some of its own high-end CAM programming tools. So it's kind of a summary of those two platforms and how they work together and kind of what they excel at. hopefully that was informative for you guys. I'm going to go ahead and pass it back over to Carl to wrap things up a little bit. And then if you have any questions, make sure to fire those into the chat so that we can get those answered for you.
All right, Ed, can you see my screen okay?
Yep.
Perfect. So one of the things I really like about these presentations, and been doing this stuff a long time, is this was live. These were real picks and clicks. And the fact that no smoke and mirrors, no ghost demos, all that kind of stuff, and no crashes, no lockups, nothing right. That points all to the stability and as part of the investment that Autodesk has made in this make strategy. Fantastic stuff. So Ed did a good job pointing out the fact, some of the reasons why standardization is so important, right? Everybody's looking for that productivity edge. Standardizing on a product like this across the board helps you get rid of a lot of other technology that is costly, as well as, from an onboarding perspective or just from a standardization perspective, this is going to help you do that. So whether you need something that's going to supercharge your process, like integrated CAD/CAM platform inside of Inventor or inside of Fusion, or turbocharged, right, like a FeatureCAM technology solution, we're there for you. And before we answer some of the questions that came around, I just did want to talk about there's other things. It just doesn't stop here, right? So where does this all go from here? So we can design the parts, we can simulate the parts, we can write the code, we can simulate the manufacturing stuff. But now what do you do? Where do you put the data? How do you store the data? How do you find the data? How do you make sure the data is concurrent? How do you share the data? All of that kind of stuff is what Imagineit is here for, helping you integrate this into your system. Whether it's a discovery, helping you understand which technology solutions are correct and apply to you, how we optimize and get those in and integrated into your current system, into your workflows and processes today, and then making sure that you're staying productive through the correct training and support for the technology you've invested in. We do this through a number of offices and a number of engineers spread all over North America. So whether you're on the East Coast, West Coast, North or South, we have offices, engineers, and account managers there to support you. Hopefully there's a push pin near where you guys are. It also goes to show that you're not relying on one person. Ed's one of our premier technical expertise on this technology, but I have them all over the country. So if Ed is busy or he's out or he's on vacation, or like he said, he's out buying his boss a Christmas present of a Fusion extension. I like that, Ed. I'll expect to see that. We have lots of resources to go to and get these questions answered. So we'll answer. I've left the URL on the screen that you guys can go to for more information on our CAM solutions, contact information, all that kind of good stuff. We'll call that wrap with the slide deck. Lori, are you still there? I know she said she was having problems with her internet going in and out, so she might have gotten booted. I see a question that came in, Ed. I think this one's for you. It said, did you say that FeatureCAM can import Creo model files?
Yeah, that's correct. So like I mentioned before, you can import in Creo. So your PRT files or your .asm file, I believe it is, with Creo. You can also bring in a solid part from SolidWorks, as well as Inventor.ipt format. And it can't necessarily read all of your like modeling data, but it will bring it in as a combination of solids and surfaces, depending on what it is. And it can read family tables. So if you have like multiple configurations of a part or something like that, it can handle that as well. So it does a good job managing files from really any standard CAD platform.
Perfect. So I think you're seeing the bend here, right? So whether their solution is it needs to be more productive is probably not questioned. That's why you're here. You're here to see how much more productive you can be from the manufacturing side. So whether the solution involves Fusion and the integrated tool sets there, or whether they involve something world-class, high-end productivity like FeatureCAM, we're here to support you. So we will call that a day. I'm going to stop the recording here, and